I really like languages, all kinds of languages, functional, imperative, or logic-based, and I really like Objective-C, and I really like Ruby, and I like to compare different languages, their syntax and their semantics. And so I thought it would be very fun to compare Objective-C and Ruby, because I think their syntax is like, they couldn't be more different, maybe. But their semantics, like what you actually do and write and what happens, is very similar. As Laura already said, I'm Mikael Konutgan, and I'm an iOS developer in Vienna at All About Apps. So, why Objective-C? We want to make iPhone apps and iPad apps because iPhones are awesome, and it is, according to Apple at least, the most advanced operating system in the world. So, and Objective-C is the native language of iOS. All the frameworks are in Objective-C, and the frameworks are written such that they work great with Objective-C. Also, Macs use Objective-C, and even if you don't want to use Objective-C and you want to make iOS apps or Mac apps and you want to use something like MacRuby or RubyMotion, it helps a lot to know Objective-C and know how it works, because these are the same limitations you have with RubyMotion, or like why RubyMotion is a way it is because of Objective-C. So first, I want to look at a quick example just to get a taste of it. So here we have some simple Ruby code, a simple array, and we're going to iterate over it and print out a string. And this is how it looks in Objective-C. Actually, I'm just kidding. This is what people think it looks in Objective-C, because that's how it looked like 4 or 5 years ago. So you have to send a message to NSNumber to get a number object, and you have an array. And you can only have objects in arrays, not actual numbers. So you have to box them all and then put them in an array. And if you make an array, you have to release it because it's like C, and you have to free memory. Also, we need to use a for loop. But Apple is improving Objective-C every year. The language is improving, the compiler is improving, and the frameworks are improving. And this is how I would write it today. So as you see, we have array literal, we have object number literals, and I can iterate over it using it like in each method, and it's called enumerate objects using block. Yes, block. We have blocks in Objective-C just like Ruby, and that's a block that takes 3 parameters. So it's basically Ruby, Objective-C. And they're very similar. Of course, Objective-C is like typed and a bit more verbose, but they're very similar. So Objective-C is a strict superset of C, as you've heard today, if you were there with the RubyMotion talks. It's object-oriented, of course, but everything is not an object, like maybe Java, where like you have numbers that aren't objects. You need to box them. It has a dynamic runtime, and you can do static or dynamic typing. So you don't actually have to type the objects if you don't want to, but it's still a good idea, like, and most developers do it. And in modern Objective-C, we have object literals for arrays. We have automatic reference counting, so we don't have to actually manage your memory for objects. And we have blocks. We can enumerate things, and we can actually make domain-specific languages just like Ruby, because we have introspection and blocks. So it's a strict superset of C, as I said before. So everything that works in C works in Objective-C. So every C program is a valid Objective-C program. And control flow is like C, if, while, for structures. Then you have your primitive types, int, long, char, void, star, etc. You can use the whole C libraries and the Unix system calls because, of course, iOS is Unix and Mac is also Unix. Then one small thing, because C didn't used to have a Boolean type and Objective-C was written at the time, even though C does have a Boolean type now, we have this big bool and yes and no, so instead of true and false. But that's a small minor thing. So let's define an Objective-C class. What I'm going to do now is I'm going to go through the slides. We're going to create a simple user class, and I'm going to show you the Objective-C version and the Ruby version. So class user. In Objective-C, it's a C-based language, so we have a header file and an implementation file, so .h.m. We call it an interface, so the superclass is NSObject. It's not implicitly object like Ruby or other languages. We have to always say NSObject, unless you want to have a object that doesn't have a superclass, but that's another story. The implementation file, it has to exist, but it's empty for this case. Then we want accessor methods for name and last name. Previously, you would have to write these yourself and define instance variables. Ruby does this for you. Objective-C does it for you too now. So it's called a property, 2 strings. Don't worry about the copy and non-atomic part for now. The implementation is still empty. Again, last year or like a few years ago, you would have to write synthesize, which generates instance variables for you, name, underscore name, underscore last name. Nowadays, you don't have to do that either, so that's enough still. And then you can implement the initializer in Ruby, just set the instance variables with the 2 parameters. And in Objective-C, you can declare the method. So don't worry about the method syntax for now. I'm going to come to that. So init with name and last name. And then in the implementation, you would implement the method. So again, basically, we're doing the same exact thing. We're setting the instance variables to the method parameters. And this is a joke I saw some time ago. Because Objective-C is like verbose and typed, so when you write a method, very often times you write the same thing like 3 times. So, do you know the Muffin Man, the Muffin Man, the Muffin Man? Using classes, so, and this is how we use Objective-C classes. So in Ruby, you would just say like user.new, we have a user, we can get the user, and then we can set the user. Objective-C is basically very similar. We send a message to the class kmuser, and then we can set the user with this dot syntax and get it. And also we have this message sending syntax. That's what actually happens. This dot is just like a convenience that also happened recently. And I will get to that in a bit also. So Objective-C messages. So this is what messages look like. They're long strings with colons. Each colon represents a parameter. So this first method, init with name, that would be a parameter, name, and last name is also a parameter. So each parameter also has a name. So like it's like the new Ruby 2 keyword parameters. And this is also a very long method name. Replace objects in range with objects from array range, which is a method on an array, which it's what it suggests. Here again is the method. So the first minus is a minus or a plus. It shows that it's a class method or an instance method. Minus is an instance method. Then you have the return type. Don't worry about the stars for now. User is the return type, and the first parameter is name, and the second parameter is last name. And the whole selector method is init with name, colon, last name, colon. So in Ruby, you would call a method like this. Just for example, if we had a person object with a say hello method, we could call it with the string Lucas. In Objective-C, you use these square brackets. So person say hello. Lucas is the parameter, and person is getting the say hello message. Like it's the small talk method, message sending way. Also, like I said, Objective-C is fully dynamic. So in Ruby, you could just send a method like this, for example. Objective-C, you can do preform selector. So like selector is fully dynamic, even though it doesn't look like it though. So like you can actually get a selector object from a string. This can be any string, and you can send the message, pass it around. So it's really dynamic. Objects are all C pointers, but you don't have to ever worry about that. Okay, not ever, but mostly. Just put the star there, and sometimes when things happen, it's good to know about pointers, but basically you can do everything without worrying about that at all. And foundation is where it's like the standard library of Objective-C. So it defines all things like arrays and data structures, algorithms, XML routines, JSON routines, date-time handling, networking, and all that other kind of stuff. And even if you use, for example, like RubyMotion, you will still be working with these objects sometimes. And in fact, in RubyMotion, the Ruby standard library is often mapped to foundation objects. In Ruby, we have string. We have NSString, array, NSArray, and hash is NSDictionary, probably the three most used classes. And we have a concept of mutability. So the string, array, and hash classes are not mutable. You can't change them after you create them. That's why we have subclasses thereof that are, you can actually change them, like add objects to the arrays or set or remove objects from them. These are for performance reasons, basically, but nowadays it's not really important. You can always get away with using a mutable variant, mostly. So in Ruby, you would use an array like this. In Objective-C, the same, almost, with the @ sign is just like the boxed expression to get an array or a string. There's a hash in Ruby. Here's a hash in Objective-C, also basically the same, with these @ signs around. You might be wondering why I have NS, KM, all these little 2 or 3 letter prefixes before classes. The reason is that we don't have like modules or namespaces, so we just, each class has a few letters before it to prevent namespace issues. And NS stands for Next Step, the company that Steve Jobs founded when he got kicked out of Apple, and that's where he started to use Objective-C. Duck typing is something that like scripting languages are famous for, and Objective-C can be duck typed. So you can use, for example, like in Ruby, you can check if an object responds to a method like this. In Objective-C, you can do this. And in Ruby, you could have like sender. It's not typed. You can check if it's an array or a hash and do something else. In Objective-C, you can see the type there ID. ID is just means basically it's an object, but I don't care which type it is. Then you can check if the class is a button or a different class and do something else. So Objective-C also in this sense is like Ruby, that you don't actually have to type objects, but it's a help to the compiler and to the person who's reading the code to check blocks. In Objective-C, you can use blocks to enumerate, to pass code around, asynchronous tasks, and blocks are closures, just like Ruby. Again, here's a Ruby block or a lambda after 1.9, and you can call it. Objective-C, that's a block. Again, it's typed, so that just basically says it's a block that returns nothing, void, and doesn't take any parameters. And then you can just call it like a normal, as if it were a function. And you can do like concurrency with blocks. In fact, that's the reason that blocks were added to the language. Like you can do a long running task in the background with this block, and then when you're done, you can run something on the main thread and update the UI, for example. How to declare blocks? Basically, we don't know because it's so difficult and a bit strange. And we have the site like fucking blocksyntax.com, and it's not a joke. I use it every day to check the syntax of blocks, and we all do. Domain-specific languages. So if you have blocks and you have introspection and you have duck typing, it helps you to create domain-specific languages. That's why you can have crazy things that don't look like programs in Ruby, and we can do the same thing in Objective-C. Like here's the bacon testing framework. It doesn't really look like code, like to a person who doesn't really know about Ruby, he wouldn't guess it's Ruby, but it is valid Ruby code. And this is a testing framework in Objective-C. Also looks like kind of like code because of the semicolons and things, but also like very expressive syntax to test things. The Objective-C Runtime, Joshua mentioned it today if you were in his talk. It basically, that's how you would include it, by the way. You have a set of C functions that all your Objective-C code gets compiled down to. So you can actually create classes on the fly at runtime. Just like Ruby, you can enumerate the instance variables of a class. Just like Ruby, you can add methods to a class, remove methods from a class, switch around methods, set the superclass of an object at runtime, change its class hierarchies, and do crazy things like that, all at runtime. Of course, I wouldn't recommend it in production, but it works. And it also shows like that it's fully dynamic and like Ruby. Tooling. We have Ruby Gems and Bundler to like manage dependencies, install dependencies. Recently for Objective-C, we have CocoaPods. So like you can actually, it's like Ruby Gems. In fact, it is a Ruby gem. It's written in Ruby to install dependencies in Objective-C and set and install them and stuff. So that was my talk. Not very long. What I tried to show you here is that like Objective-C is not some kind of alien and crazy language. Nowadays, modern Objective-C is very expressive, it's very dynamic, it's very nice to work with, and it's a great choice, and in my opinion, the best choice to write iOS, iPad, and Mac OS X applications. So where to go from here? These are actually links, so I will provide a link to my slides via Twitter, or maybe if we have a site for all the slides, you can click them. I've listed a few books, and thank you. Questions? Also, since we have time, I could do like show you around Xcode a little bit, maybe 5 minutes, start and make an iOS application and run it. Or I could answer more questions or something like that.
Okay, are there questions? So maybe after, if there's time, we could go for the demo. Okay.
Okay. So, need to mirror my display. Okay, so Xcode is an app on the Mac App Store. It's free, so you can just get it. And I'm just going to create a new application now. And like usually I start with a single view application. Let's make it an iPhone application. You can save it somewhere. And you get a basic project structure here. So this is here are your classes. That's a view controller. and you have a main, like a storyboard file you can use. This is where like often you can do your interface here. I often also just usually do it like in code. Because I like it better, and as a programmer, we're better with code, I think, than like I am better than at like moving around buttons 1 pixel at a time, and like that I can just say 10 by 10 and it's right there. And then you can the application starts like right here. Application did finish launching with options. Basically, after this point, your code starts to run. But if you have a storyboard file here, then the runtime starts the storyboard, and the storyboard's first view controller, it's like a unit of like a screen. One screen, the iPhone screen, shows a view controller, and it has a class. And here it is, and that class is right here. So in this case, my code would start right here in the viewDidLoad method of the first view controller. And I can just run this file, and wait a minute, yes, I will run it at a 64-bit 4-inch application. And this is already a fully functioning iOS app. That will scale the window a little bit. It's just a white screen. And that's how the application would look. So this is the iOS simulator. When you download Xcode, you get it right there. And you can test everything here. It works really, really well. So like oftentimes you can get away with developing just the whole application here. Of course, you can also test on the device. It's really fast, and like you can make changes, and it's almost instantaneously, like almost, even though you have to have a compile step, because things get like cached, it's almost as fast as just really only a browser, oftentimes. And then how it works, usually with the UI, you have different view controllers. You can also add them in the storyboard. And then different view controllers, you can add buttons here, or like different components. And then you can connect them with code, and then you can add new view controllers to the screen and pop view controllers from the screen, and that's how like you develop applications. Like it's all model view controller, just like Rails. So this part would be the controller part. Then you would make like a model object, and then you can make your own views, or just use different views that are already available, like buttons or labels or that kind of things. Yeah. Any questions now? Maybe. Okay. Thank you again for listening.